Welcome back to ASA. In this video, we're going to look on momentum and impulse. We're given a problem. A trolley A of mass 7.2 kg moves to the right at 0.4 meters per second in a straight line on a floor. It collides with the stationary trolley B of mass 5 kg. After the collision, the trolleys lock together and moves to the right. Ignore the frictional effects. So we have two diagrams here. This is the diagram before the collision. We have this trolley, which is trolley A, and this one, which is trolley B. Okay, so after the collision, we're going to have trolley A and B locked together. They have collapsed. So this is what we have. And we have some few questions that we have to answer. So the first question is to calculate the magnitude of the velocity of the trolleys immediately after the collision. And the second question is to calculate the average net force exerted by trolley A on trolley B during the collision if the net collision time is 0.02 seconds. So what is happening in this question? We have trolley A and trolley B. So trolley A is going to move and it is going to hit B. After hitting B, the trolleys are going to move together and they're going to stop. Right, we define momentum. So momentum of a body of mass m having a velocity of v is given by mv, meaning momentum is the product of mass and velocity. So the units for momentum are Newton per second. So as you can see, mass is going to give us kg and v is going to give us meters per second, and that is same as Newton per second. So the formula for momentum is given by mass times velocity. We can also calculate the change in momentum. So the change in momentum is going to be mass times the final velocity minus mass times the initial velocity. So the impulse of a constant force is defined as Ft, where F is force and T is the time at which the force is acting. So the units for impulse are the same as for momentum, it's 2 newtons per second. So the formula is Ft. And as you can see, the symbol for momentum is P and the symbol for impulse is J. Now let's take a closer look at impulse. We say that impulse is given by Ft, but note that force is equal to mass times acceleration from Newton's second law of motion. So that means you can write impulse is equal to m at. We have replaced F with ma, and we're going to write that as equation number 1. But from constant acceleration equation, I'm assuming that you are familiar with them. We have a equation v equals to u plus at, where v is final velocity, u is initial velocity, a is acceleration, and t is time. So as you can see, we can make a t-circle with the formula by subtracting u from both sides, and we're going to be left with v minus u is equal to at. And now we can substitute equation number 2 into equation 1, meaning we're going to have j, which is impulse, as m v minus u. So as you can see, impulse is same as change in momentum. Because from here, you can see this is same as m v2 minus v1. Okay, so now we have everything we need. So let's start with the questions. Okay, so I'm going to start with question number 1. So determine the velocity of the trolleys immediately after the collision. So determine the velocity of the trolleys after the collision. I'm going to consider conservation of linear momentum. So what does conservation of linear momentum states? It just says that initial momentum is equal to final momentum, because momentum is constant. It's not going to change unless acted upon by an external force. So that's what we're going to do. So we're going to say P1 is equal to P2. And if we use this equation, we can solve our problem. So for the initial momentum, we're going to have mass of trolley A times velocity of trolley A. And if you want, you can even add mass of trolley B times velocity of trolley B. But since trolley B is stationary, we're going to get 0. Then on final momentum, since trolley A and B are going to collapse, so their mass is going to become 1. So we're going to add the total mass and we're going to have a common velocity since they're going to move together. So we're going to have ma, mass of trolley A times v1, and on final, we're going to add them together. So now it's a matter of substituting. For ma, we have 7.2, and the initial velocity we're given 0.4 meters per second. And for ma plus mb, it's going to be 7.2 kg plus 5 kg times the velocity that we don't know. And now it's a matter of solving. So if we say 7.2 plus 5, we're going to get 12.2 kg And now we're going to divide both sides by 12.2 kg. We're going to find our velocity as 0.24 meters per second. So that is going to be the final velocity of the logged trolleys. And now we're going to move to the second question. The average net force exerted by trolley A on trolley B during the collision if the net collision time is 0.2. So whenever you see time, just know you're going to deal with impulse. So that's what we're going to do. So what do we know? We know that impulse is force times time, and we've also proved that impulse is equal to change in momentum. They say change in momentum is mass times final velocity minus mass times initial velocity. And that thing you have to take note, on physics, you have to take note of the direction. In our case, we have a very simple question, but in the next videos, we're going to solve problems in which direction will matter. But in this case, they're going in the same direction. Okay? So now, we have mass for initial momentum and for final momentum. They said since the board are going to collapse, we're going to add the final mass. And if we do that, we're going to get our change in momentum is 0.04 Newton per second. And now, what we're just going to do, we're going to use the first equation, G equals to Ft. We have the change in momentum, and we're going to equate it to force times time. So to be left with force, we're going to divide both sides by T. And we know what is T from the equation. T is 0.02 seconds. And if we divide, we're going to get 2.4 newtons. And that is going to be the force exerted by trolley A on B. So thank you for watching. If you like this channel, please don't forget to subscribe and just like. You can even comment. If you have any question, you can just email me or comment below and I'll answer everything. Thank you for watching.